Okay, so today I want to go through and show everybody the process of programming the Tormach ZA6. Just simple walkthrough of the Tormach Robot Programming Language and what that interface looks like. What we're going to do is I've got this button box here, and I have programmed the robot to be a robotic cameraman for some projects. So I'm going to show you how I went about that process and a couple different ways that I went about doing the position selection, how we jog the robot, and how we actually teach points on the robot. So with that, we'll jump over to the computer and start up Robot or Path Pilot Robot Edition. And when we start it up, it'll tell us the latest release. This is a beta version, so everything I show you is subject to change. Currently, there is 3 different configurations that you can run. There's a simulation configuration that will run without the robot being powered on, and it will let you kind of test out your programs. This mastering is to help zero the robot out, and then the standard ZA6 configuration, which we're going to run, gives you a fully functional robot. Start that up, and I'm going to take the robot out of eStop. And once it's fully set up, power the drives on and take the robot out of eStop. Now, if you've ever used a Tormach machine before, this interface should look very familiar to you. It is Path Pilot, but instead of being based off of Linux CNC, this is actually based off of a combination of ROS and MachineKit. So MachineKit is handling HAL communication and any real-time stuff that's going on, and then ROS is actually handling all of the position guidance. It's doing the robotic preview and some other stuff. So this gives us a graphical representation of the position that the robot is actually in. And if I wanted to, I could add in a representation of the camera that's mounted to the robot, so we'd have a collision model of the face of the robot, but I haven't done that. And I'll just give you a high-level overview of what the interface looks like. So if we wanted to jog the robot around, if you've ever used ROS for a robot before, this interface should look very familiar. This is the ARviz Interface. And we can just kind of drag this virtual robot around. Maybe reposition the head a little bit. And then when we do that, turn the speed down. I can hold this button, and the robot will move to match the virtual robot. All of those positions are planned using ROS, and they're really quite neat. Other things that you could do, you can jog using Cartesian axes, so X, Y, Z, and then we can rotate about those axes. And we can jog in steps. So if we wanted to jog in short increments or longer increments, we can do that. But showing you guys what the jog is about isn't really what I'm here for. So one of the other really interesting things that we can do in Tormach is we can conversationally program our machine paths. So in the Path Pilot CNC interface, we can do paths like an area clear or a face operation or a drill pattern. Same kind of idea with the robot, where we can program waypoints, set digital IOs on and off, do wait commands, notify connect to a PathPilot machine, or send MDI commands, create subprograms. A lot of the things that you would want to do in a programming language, we can do through this conversational interface. So we have two different types of waypoints, and waypoints are simply positional points that we create. And the way we can create those is, so I've jogged the robot to a new point that's not saved. If I click create new waypoint from this position, I can create a global waypoint which will always be accessible and is always saved out. Or I can create a program waypoint which is specific to a single program. And I can either capture it as a pose, which captures more data, or I can capture it as joint values. And I haven't really found a time when I want one versus the other yet. I'm sure it will come out. Oh, joints, I just stated in the tooltip here. Waypoints of this type are not affected by work offset coordinate systems. So whenever we create something where we have a work offset based around a fixture or any type of orientation, and we wanted this waypoint to always be in kind of world coordinates, we'd use the joint value. Learning something as I'm making this video. Neat. So I'm going to save this out, called cameraman underscore if. Sure. Oh, okay, there it goes. All right, so what we see here is a whole bunch of if commands, and I'm going to take you through how I created these. But once they are saved, we have our kind of block program language here. Once they're saved, if we go into File, we can see that this is all actually Python code. So the Tormach Robot Programming Language is all vanilla Python. So anything you can do in Python, from basic math to making your machine talk, is all available to you. And what the Tormach guys have done is give you some nice functions, like the getDigitalInput function or moveL function. And these are tied back to useful things like we go into our status screen, I can see what my input statuses look like. So if I push the red button, you can see that that input changes. My inputs are currently wired as normally closed, so they're always true. And then they go false when I push the button. Or we can call up the positional data. If we look in our program waypoints, these are all the waypoints that I created for this program. So we can call all of these using the moveL, moveJ, or movef commands that are functions built into the robot programming language. So let's kind of quickly run through how I created this program. So if we go to conversational, and you don't want to do new, because I don't want to lose all these points. So let's go to File, and load program, and back into conversational. So this program runs through the same points, but it's doing linear moves and then waiting for the button input to go low, and then it will move to the next command and wait for the button input to go low, and so on and so forth. So if I run through this, if we hit cycle start, I'm going to slow the robot down just a little bit. I hit cycle start. And just so everybody's aware, I am out of reach of the robot. So I'm in a perfectly safe position where I'm at. If I get much closer, I'm not. But yeah, the robot's under control, and I am outside of the robot zone. So if I hit the red button, the robot will move to the next camera position. And if I hit the purple button, it moves to the next camera position. And if I hit green, it'll move to the next. If I hit the yellow, it'll move to the top-down position. And here I have to hit red and purple to move to the next one, the way I programmed it. And if I hit red again, it goes back to the old position. But I want to be able to go back to the position that I was just at. And this is why I wrote the if program that I showed at the beginning. So I'll show you guys really quick how easy it is to change the programs around, and we can maybe make some other ones. So if we hit stop, get out of the program, I'll do a save as, and we'll give it an excellent, meaningful name. And what I'm going to do is I'm just going to click the cursor for where I want my next line to be. We'll go into control structures. And in if, I'm going to make an if statement that says if the red button was pushed, we can move on to the next statement. Now, as it sits, it's not ultra intuitive on how to do this, so we kind of have to jump back and forth and look at how the program is written. But if I look at how the actual code gets compiled once it's out of conversational, I can see that we're going to use the getDigitalIn function, and then the argument is red, and it equals false. So we want to make an if statement that looks like this. And currently we have this. So we have while getDigitalIn is red is true, it will move on. And we want to get to this if statement here. So go back to conversational and type this in. Get digital in red equals false. Since we want it to go low, we'll click add to program. And then currently the if statement is empty. There's nothing happening after it. Well, what I want it to do is I want it to go to this linear move, FPZ sawhorse. So I want it to go look at the sawhorse if I hit the red button. So I'm just going to drag this up into the if statement and hit delete for this wait. And I'm going to go through and do the rest of them similar to this. So we'll hit, whoops. And we'll do purple. Add it to the program. Drag and drop this guy up. Delete the purple statement. Add it to the program. Delete the green. And then this is a special case because I need to hit red and purple at the same time to move to the next one. But I only have 4 buttons and I've got a bunch of positions that I want to go to. So what we're going to do is we'll do a nested if statement. So we're going to say if red is false, and then if purple is false, and then I can drag this if statement into the above if statement. This guy here. And we'll do a similar thing to get back into the, oh wait, these are the same position. So we'll just delete this, and we'll delete this top statement here. And now this program should work. So we'll save it. When we save it, it activates it, puts it into main. We can see all of our if statements that we created here. And we can run it and see how it goes. So I'll hit cycle start. We ran into something. Name plus. Let's look. I see what I did. So if we need to change a statement, we can just double click on the statement really quick to edit it. So this makes troubleshooting pretty easy. So far, most of the error messages have been quite descriptive and made it easy to track down what the problem was. Overall, this has been a pretty enjoyable experience to learn how to program. But it is quite a bit different than a typical industrial robot, I will say that. Not having to be hunched over a pendant has been nice, but there's also the downfall of not having a pendant and having to program from a PC that makes it a completely different programming experience than an industrial robot. So let's see if it likes this better. Clear the messages. Cycle start. Okay, this is what I was hoping it would do. So program's going crazy. It's running in a loop. It's waiting for any of these if statements to become true. And the speed at which the program runs is actually kind of a boon for what I'm trying to do, because all I have to do is hit one of the buttons and the robot can move to that position. So I hit the purple button, it moves to the purple position. If I hit the green button, it'll run to the green position. All of these positions were pre-tested to make sure that they were a relatively safe movements to move between. So, if you're going to do something like this on your robot, pay attention to the movements. But it's pretty neat to be able to test all these out and quickly run through them and have this program prototyped out in an hour or so on this super easy to program robot. These are just simple arcade buttons. There's nothing special about them. They're simply running into the input ports on the robot. And I don't know, overall, I think this is a really powerful tool to either start up a shop on automation or get into robotics as a researcher. This has been a really neat tool to get going on. So this is the first one I hope is a lot of videos on how to program this thing and how to utilize it in more and more interesting ways. And if you like it, let me know. If you've got questions or things you'd like to see me do with the robot, I'm totally open to doing anything that I can actually accomplish. So, yeah, with that, this one's done. Later, guys.